Welcome back. In this video, we will solve all the numericals from exercise 2B. The good news is that most of these questions are based on just two simple formulas. Potential energy equals to mgh and kinetic energy equals to half mv square. If you know when and how to apply these two formulas, you will be able to solve almost every question in this exercise with confidence. So let's begin. Let's look at question number 1. Two bodies of equal masses are placed at heights h and 2h. We have to find the ratio of their gravitational potential energy. So this is body 1, body 2. Mass is equal to m and here mass is equal to m. Height is equal to h and here height is equal to 2h. Ratio of their gravitational potential energy. So gravitational potential energy is equal to mgh and here gravitational potential energy is equal to m into g into 2h. We have to find out the ratio. So ratio, let's say this is 1 and this is 2. So gravitational potential energy 1 upon gravitational potential energy 2 equals to mgh by m into g into 2h. M will cancel, g and g will cancel, h and h. So one time ratio will become 1:2. This is our final answer. Question number 2 is, find the gravitational potential energy of a 1 kg mass kept at a height of 5 meter above the ground. So mass equals to 1 kg and height is equal to 5 meter. Gravitational potential energy GPE I am writing. So mgh, which is 1 into g, they have told to use 10. So 10 and into height is 5, so 5. So we will get 50. And energy, the unit is joules, so it will be 50 joules. Right? Kinetic energy, when it falls and hits the ground, kinetic energy will be same, that is 50 joules. Why? Because the same potential energy is converted to kinetic energy. So whatever was the potential energy, 50 joules, that same will be the kinetic energy, that is 50 joules when it falls and hits the ground. This is according to the law of conservation of energy. Let's see question number 3. A box of mass 300 kg has gravitational potential energy 29400 joules. Find its height above the ground. So mass is equal to 300 kg and gravitational potential energy is given how much? 29400 joules. We have to find out the height. So we know that gravitational potential energy is equal to mgh. Now just substitute the values. 29400 equals to 300 into g, they have told to use 9.8. So we will take 9.8 into h. Now we have to calculate h, just solve it. 29400 upon 300 into 9.8 equals to h. Just solve it. So we are getting height is equal to 10 meter. Let's see question number 4. A body of mass 10 kg falls from a height of 20 meter to 8 meter. Calculate loss in potential energy. So loss in potential energy will be mgh1 minus mgh2. So we can take mg as common and h1 minus h2. So mass is 10, we will write 10 into g, they have told to use 10. So 10 into 10 and h1 height was 20 and then 8 meter. So 20 minus 8 and now only calculate 100 into 12 which is 1200. We are calculating energy 1200 joules. This is the answer. Let's see the next question. Question number 5. calculate the height through which a body of mass 0.5 kg is lifted if the energy spent is 1 joule. So we have to calculate the height. Now again we will write that mgh equals to the energy which is 1 joule. So mass is given how much? 0.5 kg. Gravitational potential energy they have told to use 10. So we'll take 10 and height we have to calculate. So this equals to 1. So height is how much? 1 upon 0.5 into 10. Just calculate, remove the decimal into 10. So 1 upon 5 meter, which will come as 0.2 meter. Let's see the next question. Next question is, a boy weighing 50 kgf climbs from the first floor to the third floor. Find the increase in gravitational potential energy. What is the increase in gravitational potential energy? Same way we will do increase in gravitational potential energy is equal to how much? mgh1 minus mgh2. So mass was 50 and they have told n, take g as 10. So 50 into 10 and height from third floor to ninth floor. So h1 minus h2, we will take 9 minus 3 which is 6. So 50 into 10 into 6. Now just calculate 6 into 5, 30 and the 2 zeros. So 3000 joules is the increase in gravitational potential energy. A vessel containing 50 kg of water is placed 15 meter above the ground. Taking the gravitational potential energy at the ground as 0, find the gravitational potential energy of the water in the vessel. So simply we have to do mgh. M is how much? 50. G they have told to use 10. And height we have lifted it by 15 meter above the ground, 15. So what we will get? 15 into 5, 75 and the 2 zeros. So 7500 joules. Question number 8. A man of mass 50 kg climbs a ladder of height 15 meter. Calculate work done. So work done is equal to force into displacement, or we can also write mgh. Now man's mass is given 50 and g they have told to use 9.8 and height he climbed is 15 meter. And after solving we should get the answer. Let's see, 15 into 5, 75, 75 into 98. So we will get 7350 joules after solving. Next they are telling increase in potential energy. So same will be the increase in potential energy because initially there was no height. So this is only the increase in potential energy, 7350 joules. Let's look at question number 9. A block weighing 100 Newton. So this is the block, weight is 100 Newton, is pulled up a slope of length 5 meter by a constant force F is equal to 100 Newton. Work done by the force. So work done is what? Force into displacement. Force they have given 100 Newton. So 100. And displacement is how much? 5 meter it is going. So 100 into 5 which will be 500 joules. Then increase in potential energy. What is the increase in potential energy? So if you see this block, it gains a height of 3 meter only. So increase in potential energy will be how much? Increase in potential energy is equal to mgh. Mass m into g they have given 100 Newton. So 100 and height that it rises, the block is only 3 meter. So 100 into 3 which is 300 joules. And they are telling explain the difference between the work done and increase in potential energy. So work done is along the slope and displacement is 5 meter, that's why it is 500 joules. But gain in potential energy is the gain in height and the height gain is only 3 meter, that's why increase in potential energy is 300 joules. Let's see the next question. Find the kinetic energy of a 5 kg body moving at 10 meter per second. So kinetic energy formula is half mv square, which is half into 5 and v is 10. So 10 into 10. 2 5 times 5 into 5 25 into 10 250 joules. Simple question. Next question. Next question is if the speed of a car is halved, how does its kinetic energy change? Very important question. So first case, second case. So the same car, so mass, here also mass is m, here also mass is m. Speed, here the speed is v and here the speed is halved. Car speed is halved, so v by 2. So kinetic energy is how much? Half m v square, and here kinetic energy is half m. It's not v by 2, v by 2 square. And we have to simplify this. What we will get? We will get half m v square by 4. If you see half m v square, and let's name it as kinetic energy 1 and kinetic energy 2. So kinetic energy 1 is half m v square. In place of half m v square, we will write kinetic energy 1. So kinetic energy 1 upon 4, which means that the kinetic energy, when the speed of the car is halved, it becomes 1/4. So that's the answer. Let's do next question. Two bodies of equal masses move with, so two bodies have equal masses. Mass. So there is body 1 and body 2. Mass is m and here also mass is m. Speed. Speed is v and here the speed is 2v. Find the ratio of their kinetic energy. So kinetic energy 1 is half m v square, and here kinetic energy 2 is equal to half m 2v square, which means half m 4v square. So again look, kinetic energy 1 is half m v square. So we can write half m v square as kinetic energy 1. Kinetic energy 1 into 4, which means the kinetic energy, when the mass of the body, when the speed of the body is doubled, will become 4 times. So the new kinetic energy is 4 times of the original kinetic energy when the velocity is doubled from v to 2v. Okay, let's see the next question. Two bodies have masses in the ratio 5:1 and kinetic energy in the ratio 125:9. Find the ratio of their velocities. So again, body 1, body 2. Mass in the ratio 5:1. So mass is 5x and here the mass is 1x. And kinetic energy ratio is 125, let's say y, and here 9y. And we have to find the ratio of their velocities. So we know that, let's name it as kinetic energy 1 and kinetic energy 2. Mass 1, mass 2. So kinetic energy 1 upon kinetic energy 2 will be what? Half into 5x into v1 square upon half into 1x into v2 square. And let's put the value of kinetic energy 1 and 2. So we will write 125y upon 9y is equal to, and let's simplify here, half and half, x and x we will cancel, and we are getting 5v1 square upon v2 square. Let's again simplify 5 25 times. So what we are getting, v1 and y also we can cancel. v1 square by v2 square is 25 by 9. So I will write v1 square by v2 square is equal to 25 by 9. So v1 by v2 is equal to root 25 by 9, which will be equal to 5 upon 3. And this is the ratio of their velocities. This is how we can calculate. Let's see the next question. Two similar cars move at 15 km per hour and 45 km per hour. Find the ratio of their kinetic energies. So, kinetic energy 1 upon kinetic energy 2. Similar car, which means mass is same, m into, and it is half m v square. Velocity is 15. 15 square, so I will write 15 into 15. And this is half m into 45 into 45. Just cancel. 15 3 times and 15 3 times. So we get the ratio as, so we get 1 upon 9, and that's how we can solve the question very easily. Let's see the next question. A ball of mass 0.5 kg slows from 10 meter per second to 6 meter per second. Calculate the change in its kinetic energy. So change in kinetic energy equals to half m v2 square, final velocity, minus half m v1 square. How we do? We can take half m common. We will get v2 square minus v1 square, which is 1 by 2 into m, and mass is 0.5. So 0.5 into 10 square minus 6 square, which is half into 5 upon 10 into 10 in 100 minus 36. You will get 64 and solve it. So how much you will get? Change in kinetic energy is 16 joules. And this is how you can solve it. Let's see the next question. Next question number 16. A cannonball of mass 500 gram is fired with a speed of 15 meter per second. Find its kinetic energy. So kinetic energy is what? Half into m into v square. Now mass is given in gram, you have to convert it to kg. So half into 500 upon 1000 into v. V is 15 meter per second. So 15 into 15. Right, there is a 15, 5, 225. So 225 upon 4. So we will get the kinetic energy as 56.25 joules. Now we have to calculate its momentum. So momentum is how much? Momentum is equal to mass into velocity, and mass is given to you as 500 gram upon 1000 converted to kg, and velocity is 15 meter per second. 15 upon 2, which is 7.5. And 7.5, what is the unit of momentum? Mass into velocity, kg meter per second. So momentum will be 7.5 kg meter per second. Let's see the next question. Question number 17. A body of mass 10 kg is moving with a velocity of 20 meter per second. If the mass is doubled and the velocity is halved, then so there is a body and there are two scenarios, 1 and 2. Mass is 10 kg, so mass 10 kg, and velocity is how much? 20 meter per second. Mass is doubled, so now the mass is 10 into 2 kg, and the velocity is halved. So velocity is 20 upon 2 meters per second. We have to calculate find the initial kinetic energy. So initial kinetic energy will be half mv square, which is half into m. The initial was 10 kg, so 10, and velocity initially was 20. So into 20 into 20. Just solve it. So 2000 joules will be the initial kinetic energy. Now they are also telling final kinetic energy. So final kinetic energy, half into, now the m is 10 into 2. And velocity now is 20 upon 2. So 20 upon 2 into 20 upon 2. And just solve and you will get the answer, 1000 joules. So this is the initial kinetic energy is 2000 joules and the final kinetic energy is 1000 joules. Next question. A truck of mass 1000 kg changes its speed from 36 km per hour to 72 km per hour in 2 minutes. Work done by the engine. So work done we have to calculate. Now change in kinetic energy is actually equal to the work done. So we can calculate work done is equal to half m v1 square minus half m v2 square. So basically final minus initial, and I will write v2 square minus v1 square. Okay. Now half into m is 1000 and in bracket v2 square minus v1 square. So let's solve this to 500. 500 into v2, speed is 72 km per hour. So 72 into 5 by 18, we are converting it to meter per second. 18 4 times. And minus v1 is 36 into 5 upon 18. 18 2 times. So we are getting 500 into 20 square minus 10 square, because it was v2 square minus v1 square, and 5 4s are 20 we are getting, so this whole square minus this whole square. So we will get 500 into 20 square is 400 and 10 square is 100. 400 minus 100 is 300. So what we are getting, 5 into 3 15 and 1 2 3 4. 4 zeros, which means 1,50,000 joules. Or we can also write 1.5 into 10 to the power 5 joules. So this can also be written 1.5 into 10 raised to the power 5 joules. Next is power we have to calculate. So power is how I have done work power question in my last video. You can go and watch. So power is equal to work done upon time taken. Work done is how much? 1/5 this much joules, and time taken is 2 minutes. We'll convert it to seconds. 2 into 60 and just calculate it now. So power will be 1250 watt. Let's see the next question. A body of mass 60 kg has a momentum of 3000 kg meter per second. So kinetic energy we have to calculate. Now first, mass is equal to 60 kg. Momentum is 3000. So we will write momentum 3000 kg meter per second. Now momentum is actually mass into velocity. So mass into velocity is 3000. Mass is how much? 60. So 60 into V is 3000. So we can calculate V as 3000 upon 60, which is coming 50 meters per second. Now we can calculate the kinetic energy. So kinetic energy will be half mv square, which is half into 60, and V we calculated 50. So 50 into 50. How much we will get? So 75000 and joules, because we are calculating kinetic energy. And then speed of the body we have already calculated 50 meter per second. So we are done. Simple. Let's see the next question. How much work must be done on a ball of mass 50 kg to give it a momentum of 5 kg meter per second? 50 gram this is, by the way. Work done we have to calculate, but momentum is given. So mass is equal to 50 gram. So 50 upon 1000 kg. And momentum is equal to 5 kg meter per second. Momentum is mass into velocity. So mass into velocity is 5. Mass is 50 gram, that is kg, 50 upon 1000 into velocity is equal to 5. From here we have to get velocity. So velocity will be 5 into 1000 upon 50. So velocity is coming 100 meters per second. Now we can calculate the work done. So work done will be equal to the kinetic energy. So half mv square. Half into m into v square. So half into m. M is 50 by 1000. And velocity we calculated 100. So into 100 into 100. Let's solve it. 1, 2, 3 zeros. 1, 2, 3 zeros. 2, 5, 10. So 250 joules. And this is the work done. Right? Next question. How much energy is gained by a box of mass 20 kg when a man carries the box while waiting 5 minutes for a bus? Man is only waiting 5 minutes. So no work is done. So first will be work done will be 0. Number B. The man runs carrying the box at 3 meters per second to catch the bus. The man is running. So kinetic energy, whatever is the kinetic energy, that will be the work done. Kinetic energy is half mv square. So half into mass of the box is 20 and velocity is 3 meters per second into 3 into 3. 2 10 times. 9 into 10 90 joules. So this is only the work done. Whatever is the kinetic energy, that is the work done. Number C. Raises the box by 0.5 meter to place it inside the bus. So we have to calculate the work done or energy gain when a man. So work done is force into displacement. Now he raises the box by 0.5 meter and box is 20 kg. So force will be 20 into 10 and he raises it by 0.5 meter. So 0.5 meter and we will get 5 into 2 10. So 100 joules. And this is how work done can be calculated. Next question. Let's look at this question. A bullet of mass 50 gram is moving with a velocity of 500 meters per second. Kinetic energy we have to calculate. So kinetic energy is equal to half into m into v square. So half. Mass is given 50 gram, which is 50 upon 1000 kg. And velocity is 500 meters per second. So 500 into 500. 6250 joules. Now you have to calculate the average retarding force. So force you have to calculate. Now we know that work done is equal to force into displacement. And kinetic energy is the work done, which is 6250. So 6250 is the force that we have to calculate. And displacement, average retarding force offered by the target. Displacement is, it has penetrated 10 centimeter. So 10 will be converted to SI unit meter, 10 upon 100. Just calculate and you will get. So 6250 into 10 equals to force. So force is 62500 Newton. And this is how you can solve it. Let's see the next question, the last question. So the question is, a spring is compressed by a small trolley. This is the spring, this is compressed by the trolley. And trolley's mass is 0.5 kg on a smooth horizontal surface. When released, the trolley moves with a speed of 2 meters per second. The trolley is moving with this speed. We have to find the potential energy stored in the compressed spring. So kinetic energy we will calculate of the trolley. Whatever is the kinetic energy, that same energy is the energy stored in the spring. So kinetic energy of the trolley is half mv square, which is half into mass is 0.5 kg and velocity is 2 meters per second. So 2 into 2. So we are getting 1 joule. So this is the kinetic energy of the trolley, and the potential energy stored in the compressed spring is same. So potential energy in the spring is same, which is 1 joule. And this is how you can solve it. That's it for exercise 2B. I hope you now feel confident solving these numericals. Keep practicing the questions on your own. And remember, the key is to identify the correct formula first. If you found this video helpful, don't forget to like, share and subscribe for more ICSE Physics solutions. See you in the next video.